Okay, Unit 7 test review. For each measurement, find A, the degree of precision, B, the range. The first number 1, 5.2037 millimeters. Degree of precision is pretty easy. You make a decimal, you put a 0 before it. Then the 1 turns to a 0. 0 will stay a 0. The 3 turns to a 0, but that last digit goes to a 1. Now to find the range, okay, make a dash because a range has a maximum and a minimum. Plus, minus, okay. Now not that number. You take your degree of precision number divided by 2. That's going to be 0.00005. So take your 5.2037, first add it, 0.00005. That's your first one, okay? That, when you add it, that's your maximum, 5.20375. Then switch it to minus, that's your minimum, 5.20365. Okay, 4.89. 0 before the decimal, then a 8 turns to a 0, but the last digit just turns to a 1. Okay. So you take your 0.01 divided by 2, and that's 0.005 plus minus. So first I add 4.8905. Then we go back to the 4.89, we subtract 0.005. Okay, 4.8895. Okay, 4.8895. Next one, A and B. 0 just in front of the you don't need to put 2 zeros, just 1's good. And then that's your last digit, so it becomes a 1. There's your precision degree. Plus minus, so you take your 0.1 divided by 2. That's the number you add and subtract. 0.05. Okay, so when I add, I get 4.85, 14.85, and when you minus, you get 14.75. Okay, add or subtract the following measurement numbers. Round answers to the degree of precision of the least precise number. Don't do the checks and the X's. You're not doing significant digits. You don't do that when you add and subtract. You count the decimal places. That has 3. That has 2. So mine needs 2. I have to put whatever's in front of the decimal though. Okay. 48 goes in front, 2 digits behind it. 34 is what that would go to. There's a 9 after it. Okay, that has 2. That doesn't have any, okay? So you need 0. You're not going to have a decimal, okay? So 382.34 minus 232. You are not allowed a decimal, 150. It would stay 150. It would not round up because that 3 does not round it up. Okay, that has 3, that has 2, that doesn't have any, so again, we're not allowed any decimal places. 56.391 plus 38.21 minus 18, no decimals. I would have to go to 77. Now, determine this number of significant digits for each of the following measurement numbers. Now you're doing significant digits. Remember the rules. Any non-zero is significant. Check, check, check. Any zeros in between non-zeros are significant. Check, check. So that has 5. Okay. Any non-zeros are significant. Any between zeros, we don't have any between. Do you have any at the beginning that you can X? No, you don't. Now zeros at the end. They are marked with checks only if there's a decimal point. There is no decimal point, so we do not count those. Leave them empty, so that's 3. Okay, any zeros on between that you can check? Nope. Zeros at the beginning are never checked, ever. Even if there's a decimal, nope. So that has 3. Okay, on 10 through 10, 11, and 12, for each of the following groups of measurement numbers, identify the most accurate number. That means the most significant digits. Okay, so let's look at the first one. Well, that's a check. The zeros at the beginning are not, so that has 1, 0.004. That's checked, zeros, so that has 1. That has 2. So the most accurate is the 0.56. You just write it. If it's a tie, you write both the numbers. Check, check, check. Zeros are at the end. Okay, they're at the end. Do you see a decimal of that number? Nope, so those don't count. That has 3. The zeros are at the end, okay? Only if there's a decimal do we check them. There's no decimal, so that's 2. Check, check, check. So it's 223's got the most. Or no, it's a tie. I'm sorry, tie between 24,500 and 223. Check, check, 16.3. Check, check, check. That has 3. Check, check. Now you got a 0 at the end. Is there a decimal point? There is, so it's checked. So that has 3. Check, check, check. The 0 in between is always checked. The 0 at the end, only if there's a decimal. There's no decimal, that is not checked. But that's still got the most significant digits, so 48,070 is your most precise, or is your most accurate number. Okay, multiply or divide the following measurement numbers. Round answers to the same number as significant digits as the least accurate number. So that has 3, that has 2, so we're allowed 2. So I punch that in, but I can only write 2 significant digits. Well, 1 and then 3, but it would go to a 4, so it'd be 14. Check, check. The zeros are at the end. Well, is there a decimal point? No, there's not, so that has 2. That has 3, so we're allowed to put 2. Now, if that had a 0.0 behind it, I would count those zeros, but there's no decimal. 4,500 divided by 234, 2 decimals, so 1, 9, so 19. And it would not round up, it would stay 19. Okay, 334.02 divided by 12.300 times 3.302. Okay. So check, 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 check. That's a between, so that's checked. That is 5. Check, check, check. Those are at the end, but there's a decimal point, so they are checked. Okay. In between, check. So that has 5, that has 5, that has 4, so we're allowed to put 4. Okay. 4, 8, 9.6, there's 3, and then that would be the 4th right there, but it would round up to a 7, 89.67. Okay, story problem time. You got this table, you got a true value and then what you measured it. Okay, so the measured value is off from the true value. Compute the absolute error, the relative error, and the percent error of each of the values in the table. So absolute error, you just minus. Okay. So 107 minus 99, just bigger minus smaller. It doesn't matter where the bigger number's at. That's 8. Okay. Relative error, you take your absolute error divided by your true value. Absolute divided by true. Okay, so the absolute is 8, and the true is 107. Now, when you're dividing and multiplying, you got to do significant digits. That has 1, that has 3. The 0 gets checked, so we're allowed 1. The zeros at the beginning do not count. You need to write those. They do not count. They never, zeros at the beginning never count. When we have a 7, that would stay a 7. So 0.07. Now the percentage error, you can either take that times 100 or just move the decimal forward. It'd be twice. It would be 7%, twice to the right. Okay, next. Larger minus smaller. 0.8639 minus 0.8634. 0.0005. Then I take that absolute error divided by the true value, 0.8639. So that has 1. The zeros at the beginning don't count. This has 4, so we're allowed 1. Okay, 0.0005 divided by 0.8639. Okay, you're allowed 1. Okay, so the zeros need to be written at the beginning. Then I get to a 5, but it would go to a 6. So either times it by 100 or move it twice to the right. It'd be 0.06%. Okay. All right. Minus those, 71.3 minus 70.6. 0.7. Now you take your absolute error divided by your true value. Now, how many significant digits are you allowed? Well, 1 there, 3 here, so you're just allowed 1. Okay. Okay, remember you're allowed 1. So the zeros at the beginning. Okay, it's a little bit confusing because there's nowhere for a 9 to go. Okay. I would just take that 0 right there and make it a 1. Then the 0 before the 9 becomes a 1. So 0.01. Move it twice to the right, and that's 1%. Okay, determine the tolerance, maximum limit, or minimum limit required. This is the formula. Tolerance equals max minus min divided by 2. So if we don't know the tolerance, it makes for a fairly easy problem. So the maximum's 18 1/4. The minimum 17 17 over 32 divided by 2. So you got to minus the top. Don't divide by the bottom at the same time. Okay. Okay, 1 1/32. Now after I hit equals, I can divide it by 2. So that would be 33/64 inches. Okay. Okay, now the next one, they give me the tolerance. So the T will not be there. The T will turn into 0.008. Maximum we don't know. And the minimum 6.502. So we're using algebra. So you times by 2, times the other side by 2, and that takes that side to 0.016, and then m minus 6.502, and then that's a negative, so to move it, you'd add it. .518, and that's your max. Okay, now your minimum. Same thing, tolerance is 0.08. Maximum we know 58, 15.64 minus the minimum. Okay, now the m's over here, over 2. Now we times by 2 the same way. So it's 0.16 now, and then 15.64 minus m. Now, unlike here where we had a negative, now we have a positive that we have to get out of there by minusing it. Now it's going to be a negative, and that's okay. Negative 15.48. And then negative m. Now, you just make those both positives and you have m. You can do that. You can make each side positive, and m is 15.48. Remember how you can check your answers. You can take the maximum and minus the tolerance, and then take your minimum and plus the tolerance. Okay. Okay, compute the missing values. Okay. A is bigger than B, so A has to be the hole and B has to be the shaft. Okay. So here are your tolerances, 0.02 on both of them, okay, up there at the top. So to find your maximum diameter, 3.34 plus 0.02, 3.36 is the maximum. And then 3.34 minus 0.02, 3.32 is the minimum of that diameter of the shaft. Now the hole, we do the same thing, 3.26, because that's B. That has a tolerance of 0.02, so over it, 3.28. You take that 3.26 and minus 0.02, okay? 3.24. Okay, and there you have it. Now, on the maximum minimum clearance, you're going to cross that out. Okay, you don't need that. You just need the top row. Okay. Now the maximum clearance. Maximum clearance is taking your highest max, highest max minus the lowest minimum. Okay. Highest max minus lowest min. Minimum clearance is taking your highest minimum minus your lowest maximum. So maximum, highest max, subtract the lowest minimum, lowest possible number. Okay. Then you take your highest minimum minus your lowest maximum. Okay. So what's the highest max? 3.36. What's the lowest minimum? 3.24. So I take 3.636 minus 3.24. That's 0.12. Okay. Then you take your higher minimum minus your lower maximum. So I subtract. That's going to be 0.04. Okay. And then it's rinse, repeat on the next one. Okay. So diameter of A, 13.05 plus 0.02, 14.07. And if I take that and minus the 0.02, it's 14.03. Now add 0.02, 13.97, and then minus 0.02, 13.93. Cross that out, okay? Highest max minus lowest minimum. 14.07 minus 13.93. That's going to be 0.14. Then you take your lowest min, or your highest minimum minus your lowest maximum. So that's going to be 0.06. Okay. Next one, last round. add 0.02, 5.27, then minus 0.02, 5.23. Add 0.02, that's 5.14, minus 0.02, and that's going to be 5.1 or 5.10. So your higher of the maximums is here, your lower of the minimums is here. So you subtract those and you get 0.17. Then you take your highest minimum minus your lowest maximum, okay? 0.03 or 0.09, excuse me, okay? Okay, now I turn the page over, number 19. A cabinet maker saws a board as shown. What are the maximum and minimum permissible values of length A? So you have to find the maximum value for A, max A, and min A. Now, here's how you're going to do this. You got the whole thing, the outside piece. I call it the outside, and then one of the inside pieces. Okay. So max outside, min outside, maximum, minimum. And then inside, okay, the max inside and the max and the minimum inside, okay, min inside. Now these are easy to find. So outside you got 50 3/4 plus or minus 1/16. So to find the maximum you take your 50 3/4 and add 1/16, and then your minimum outside you take the 50 3/4, the basic dimension, and minus that tolerance. Okay, real easy. 50 ABC3 ABC4 plus 1/16. So the maximum outside is 50 13/16. Okay. Now the minimum, you take 50 ABC3 ABC4 minus 1/16. 50 11/16. Okay. Now your maximum inside, 22 3/8 plus or minus 1/16. So it'd be 22 3/8 plus 1/16, and then 22 3/8 minus 1/16. Okay, 22 7/16 is the maximum value of that inside dimension. 22 3/8 minus 1/16. 22 5/16 is your minimum value of the inside. Okay. Now maximum of A. You know you're going to be minusing. Okay, to find A, the missing value of A, and to maximize a difference, you take your highest max minus the lowest minimum. High max minus low minimum. High max minus lowest minimum. So look at your maximums. The highest is 50 3 13/16. Lowest minimum. Well, look at the minimums. Okay, here are the minimums. That's your lowest, 22 5/16. Okay, and then the minimum. Okay, you take your highest minimum. Okay, highest minimum. It's the same thing you're doing over here. Highest minimum minus lowest maximum. It's like everything's the opposite. So highest minimum, lowest maximum. Okay, so look at your minimums. Okay, the highest minimum's 50 11/16 minus the, oh, sorry, not the low, and then the lowest maximum. Okay, here's your maximum is 22 7/16. Okay, so 50 ABC 13 ABC 16 minus 22 ABC 5 ABC 16, 28.5. Then minus, okay, 50, you take your lowest, your highest minimum, minus your lowest maximum. Okay, whoops, better punch it in, right? 50 and 11/16 minus 22 and 7/16. Okay, 28 and 1/4. Yes, 28 and a half is bigger than 28 and a fourth. Okay, next one. A sheet metal technician lays out a job to the dimensions and tolerances shown. What are the maximum and minimum permissible values of length A? So same thing. Maximum of A, minimum of A. Okay, so you got that outside. Max outside. Min outside. Okay, and then the inside. You're going to combine the insides into one. Okay, you got two of them here. Okay, so max inside, max outside. Okay, so let's talk about the outside. 26 and 7/8. To maximize it, I would add the tolerance, 1/32. To minimize the outside, you take the 26 and 7/8 and minus the 1/32, the tolerance. Okay, so 26 ABC 7 ABC 8 plus 1 ABC 32. 26 and 29 over 32. That's your maximum outside. Now you go up and minus. Okay, just switch the plus to a minus. 26 and 27 over 32. Okay. And conversely, to find the maximum of A, you start with, now the insides, you got two inside dimensions that you know. So here's what we need to do. On both of these, we need to take the 6 and 3/16 plus the 7 1/2. You're going to plus on both of them. The basic dimensions get added. But to maximize it, you add the 1 over 32, but you add it on twice for that and that. So plus 1 over 32 plus 1 over 32. Here I'm just minusing the 1 over 32 twice. Okay. So 6 and 3/16 plus 7 and 1/2 plus 1 over 32 plus 1 over 32. I come up with 13 and 3/4. That's a maximum inside. Then the maximum outside, 6 and 3/16 plus 7 and 1/2. But on this one, I minus the tolerance. Okay, 13 and 5/8. Okay, now maximum of A. You want to maximize A. So you start with your highest maximum. Here are my maximums. That's highest, 26, 29 over 32, minus the lowest minimum. So here are my minimums. That'd be the lowest. Okay, so 26 and 29 30 minus 13 and 5/8. 13 and 9/30. That's your maximum value of A. Now the minimum value of A. Okay, so you start with your highest minimum, okay, which is 26 and 27 over 32. And you subtract your lowest maximum. So here's the maximums, okay. It would be 13 and 3/4, okay. It's kind of like to maximize it, you start with the higher, subtract the lower, okay. To minimize it, you start with the lower, subtract the higher. Okay, so again, maximum, start high, subtract low. Minimum, start low, and subtract high, okay. Okay, 13 and 3 over 32. Obviously your maximum should be bigger than your minimum.